Hey there, future architects. Welcome to our second episode on building systems that don't crumble under pressure. Today, we're diving into how Netflix manages to serve content to 230 million users without breaking a sweat. Let's clear something up right away. Scalability isn't just throwing more servers at a problem and hoping for the best. It's about your system's ability to gracefully handle increased load without performance taking a nosedive. Think about companies like Netflix, Instagram, or Amazon. They don't just survive millions of users, they thrive. That's because they've mastered both the art and science of scalability. A truly scalable system stays stable, fast, and reliable even when everyone decides to log in at once. And trust me, they will. But scalability goes beyond just raw performance. It's about resilience, maintaining uptime, and doing it all without breaking the bank. In our industry, we typically approach this through two main strategies: vertical scaling and horizontal scaling. Let's break these down so you understand exactly when to use each approach. Before we dive deeper, you need to understand two critical metrics that will define your scaling success: throughput and latency. Throughput is essentially how many requests your system can handle per second. Your goal? Maximize this number without your system falling over. Latency, on the other hand, is how long it takes to serve a single request. Here, lower is always better. I like to explain this with a highway analogy. Throughput is like the total capacity of a highway, how many cars can move through it per hour. Latency is how quickly one car gets from on-ramp to off-ramp. The magic happens when you achieve both high throughput and low latency. That's when users experience that smooth, instant feel we've all come to expect. Watch out though. Many systems maintain good latency until they hit a certain load. Then response times suddenly spike. That's usually where your bottlenecks are hiding, whether in CPU utilization, database connections, or memory constraints. Let's talk about vertical scaling first, what I sometimes call the bigger hammer approach. Vertical scaling means beefing up your existing server by adding more CPU, RAM, or faster storage. It's like upgrading your laptop from 8 gigabytes to 32 gigabytes of RAM. The big advantage? It's relatively easy to implement. You don't need to rewrite your code or re-architect your application. Just throw more resources at the problem. But there are serious pitfalls. There's a ceiling to how much you can scale vertically. You can't add infinite RAM to one machine. It gets expensive fast, with diminishing returns on those high-end server components. And perhaps most dangerously, you're still relying on a single machine, which means one crash equals total outage. This approach makes sense for early-stage applications, MVPs, or traditional monolithic architectures. But if you're planning for serious growth, you'll need to look beyond it. This brings us to horizontal scaling, the approach that powers giants like Netflix. Instead of one powerful server, horizontal scaling distributes your load across multiple machines working in parallel. It's not about building a bigger boat, it's about creating a fleet. The advantages are game-changing. You can theoretically scale infinitely by continuously adding more nodes. Your system becomes significantly more resilient because if one server fails, the others keep your application running. This is the approach that underpins microservices architectures and cloud-native applications. And it's a meaningful but horizontal scaling introduces complexity. You'll need load balancers to distribute traffic, sophisticated state management to handle user sessions across servers, and possibly database sharding to spread data efficiently. Netflix, Google, YouTube, all the services you rely on daily, use horizontal scaling to serve millions of concurrent users. That should tell you something about which approach wins at scale. Here's a truth that might surprise you. Most applications don't fail because of bugs in the code. They fail because they weren't designed to handle load spikes, those sudden surges in traffic. Think about it. A flash sale announcement, exam results going live, or your content suddenly going viral. Without proper planning, these predictable yet intense moments cause servers to overheat, connections to max out, and your entire system to collapse. I've seen it happen repeatedly, like college exam portals crashing on results day. It's completely predictable traffic, but poor scaling preparation leads to failure at the worst possible moment. Netflix handles these spikes masterfully through auto-scaling groups in AWS and sophisticated load balancing. Their systems automatically detect increased demand and spin up new resources before users notice any slowdown. Tools like CloudWatch combined with auto-scaling groups can help your application breathe with the natural rhythm of user demand, expanding during peak times and contracting when things are quiet to save costs. This is where I want you to make a fundamental mindset shift. Stop thinking of your systems as static applications that you build, deploy, and forget. Successful systems are more like living organisms. They need to adapt to changing demands, heal themselves when components fail, and grow alongside your user base. Netflix doesn't just build and deploy their platform. They constantly monitor it, scale it automatically, and intelligently reroute traffic when issues arise. Remember this: good engineers write code. Great engineers build adaptable systems that respond to real-world conditions. This shift in thinking separates those who build toys from those who build platforms that last. Let's look at how Netflix actually implements these principles in practice. They use a sophisticated ecosystem of tools: Eureka for service discovery, Ribbon for client-side load balancing, and Hystrix for circuit breaking and fallbacks when services become overwhelmed. Their infrastructure leverages AWS auto-scaling groups to handle demand peaks, automatically expanding their fleet of servers when viewership spikes, like during a new season release of Stranger Things. They also employ content delivery networks to strategically position content closer to users around the world, reducing both latency and central server load. Perhaps most interestingly, Netflix practices chaos engineering with tools like Chaos Monkey, which deliberately introduces failures into their production system to ensure it can heal itself. Their core philosophy? If something can fail, it eventually will. So design your systems with failure as an expected condition, not an exception. Let's recap what we've learned today. Scalability isn't optional. It's the foundation of any system that hopes to last. Make sure you truly understand the difference between throughput and latency and optimize for both. While vertical scaling might work initially, plan your graduation to horizontal scaling early to avoid painful rewrites later. Monitor your systems continuously, just as you'd monitor your own health, because scale is literally about survival in today's digital landscape. And finally, look to Netflix as your benchmark. Don't just copy their tech stack. Understand how they think about systems, resilience, and scale. In our next episode, we're diving into Load Balancing 101, where you'll learn how to handle massive traffic like the pros. Remember, don't just react to traffic, design for it. I'll see you in next video. Before you go, I'd love to hear from you in the comments. If your app suddenly got 1 million users in 10 minutes, how would your system survive it? What would break first? If you learned something new today, hit that like button. Make sure you're subscribed for more real-world systems thinking. And get ready for episode 3 on load balancing dropping next week.